So this is the assignment which we will be trying to model today. It's basically a fairly simple portal frame, as you can see from this section over here. The only thing which is novel about it that the side is non-parallel. So this is the top view. You can see this is the normal side, but this side is not parallel to that side. So if you zoom in, you can see that it is instead of being over here, this side is 4,500 millimeters offsetted. The total width of the portal frame is 12 meters, as you can see over here, and the other direction is 20 meters, which is basically 4 bays of 5 meters each. And we will be trying to model this. So let's take a look at these notes over here. It says that the roof and the vertical bracing have been shifted at certain points as shown. We'll get to those. The eaves beam is basically a folded plate. This is this one over here. This is a folded plate, and it's folded in such a way that if we come down over here, we can see that this folded plate is folded in such a way that the top slope is aligned with the roof, and the side is aligned with the girts on that facade. So that's the eaves beam. The vertical sag rods have been shifted 50 millimeters to the left as shown. We'll get to the sag rods. All girts are UNP 120. All purlins are UNP 120. All main columns are HEA 260, except for the wind columns, which are HEA 300. So all these columns of the main portal frame are HEA 260, but these two wind columns over here are HEA 300. All roof beams are IPE 300. Those are these roof beams. They're all IPE 300. And all materials are given. You can assume reasonable values for information not provided. And once familiar with the software, it shouldn't take you more than an hour and a half to model it. That's just a challenge once you get used to the software. So let's start off with the columns. The columns on the back side will be along the line, of course, but the columns along this line will be slightly non-parallel as shown over here. So let's just study this line. This is 4,500 millimeters offsetted from that side. So just keeping that in mind, and the fact that the columns are HEA 260 as we were given. So we go back to our model. And we have the grid ready. The grid is 12 meters by 4 into 5,000. So what we can do is we can just start inputting the columns. Let's look at the height of the columns first. So the height of the columns is 5 meters. And the height at the top is 7 meters for the roof beams. So we come back to the model and we start inputting our columns like this. The columns in the drawings are facing in the other direction. So we press Control Q. Now, we can get the back columns pretty simply because they're along that line. We can just go like that, right click, say match elements to this one. They're all in the right direction now. But for this one, we first need a construction line. So let's create the construction line. It was 4.5 meters offsetted from there. So we'll hover over this point and say DX 4,500. And then we'll just come in and snap to this point. And now that we have that line, we can go in and create our other columns like that. And once we've done that, we can just go and match them to that as far as the direction of the columns is concerned. So that was pretty simple, just getting the columns inside. But of course, after entering the columns, we immediately note that while this column, the height of this column is 5 meters, this one is slightly higher. This one is slightly higher than that. This one is slightly higher than that. And this one is the highest one, because they're basically along this inclined non-parallel plane, and therefore whatever height they meet up with the roof beam, that's the height of the column. So to do that, what we can do is we can go back to the model, and first of all, let's just go in and create our roof beam for the first one, which we know is DZ 7000 from there, and then from there to there. And let's check the profile of the roof beam. It's IPE 300. So we go back to the model. I think the default is IPE 300, so that should be fine. Now, what we can do is we can actually just copy these linearly in the y direction, the distance of 5,000. We need 1, 2, 3, 4 copies. So let's just do that. So we know where the would be. These beams obviously need to be shortened, but we know at least where the heights would be. Once we have those beams inside, what we can easily do is we can just select these columns like that, and right click and go to frame editing and say extend the frames to plane with 3 points, so extending them to the roof plane basically. And for that we need to select 3 points now. So we need to just select any 3 points on this roof side, and we can select this one and this one and this one. That should be fine. And right click and interrupt, and we see that the columns have been extended to meet up with the beams, whatever the height at that point would be. Now, these beams obviously now need to be pulled back. One way to do that would be to select the beam and select this end arrow, and then come over here and say move to point, and click on the top of the column, and the beam will be pulled back. Do the same for this one, move to point this one, click on this one, click on the arrow, I'm sorry, go over there, move to point the top of the column, and similarly for the last one we can do the same thing. Just select this point and the beam will be entered as shown. Now let's take a look at the roof purlins. So we see that while the purlins on the back side, which is the normal side, are pretty okay, and they're just like you would expect. But on this side, because of this inclined, this non-parallel facade, some of the purlins are missing. So you're coming down like that, and then the last purlin over here is missing because it doesn't really have anything to connect to. So we've just basically just left it because the distance is kind of okay. And once again, for this one, the last purlin is missing, and for that one, the last purlin is missing. And similarly for this one also, this purlin is missing over there. So the other side, of course, represents the full purlin set. So if we zoom in over here, we see that the full purlin set is actually 250 millimeters offsetted from the apex point and 250 millimeters offsetted from the eaves point. And then whatever is left in the middle is divided into 1, 2, 3, 4, 5 parts. So using that as our benchmark, we can do the same thing on the left side as well, and then delete the purlins which are not really needed. So let's begin by creating our points. Go to our points command, go to our extension points, click on the shift key so that we can do the settings. We know it was 250 millimeters offsetted from the ends. So we'll just create those basic points first. From here to here, minus 250. From here to here, minus 250. We know those are the starting points for the purlins, like that and like that. So we now know that we have these points, and in between we had a total of 5 purlins. So we'll need to divide this into 4. So we go to our dividing points, and we click on this point, and then before we click on the other one, we keep the key, the number 4 key pressed, and then we click on this one, so we get these 4 equally divided spacings in the middle, and we can go and check the distance. Let's just take this 1164.911. It's let's see what the drawing says, 1165. So it's rounded it off basically. So that's correct. We do the same thing on the other side, dividing points. We click on this point, And then before clicking on this point, we keep the number 4 pressed. So we've got our points. And then we can just copy these points to the other side. Like we can just go like that, press enter to the point, get to the free points, the part points you don't need to select. Even if you do, it's not a mistake. It's not going to move them. But select the 12 free points which we've created. And we just copy them in the Y direction. Just make 4 copies like that, so that we have all the points for the purlins. Now that we have those points, we can try so the first one, this one would be missing because it doesn't have a roof beam to connect to, but this is the one we can create, this one over here. So what we can do is we can go to our steel, go to the purlins, and before we do that, we right click and we set the work plane to the surface of the top surface of the roof over there, so that the rotations come in correctly. And we go to purlin, and then we select this one and this one, and then we zoom in to see how we need to correct that. We need to press Control Q, and we need to press Control W, and then twice, and then Control E to bring it to this orientation. Let's just check the so it's actually pointing in the other direction, so we need to go back, press Control Q twice again, and then E as well. Yeah, there we have it. This is the way this one is supposed to be. And while we have this, we can now copy it along that direction linearly, like from there to there. We can say 1, 2, 3, 4 copies like that, and we have the purlins on this side. And we can do the same thing for the purlins on the other side by selecting the points in the opposite direction. I'll show you how that will help. Once we have done that, we can just select this. Let's just first set the work plane to the roof plane on the other side now. Yeah, that's better. And now we can re-enter it. It's easier to re-enter it like that. Once again, this one will be looking, let's press Control Q in the other direction like that. Control W and Control E. There we go. So we have the purlin on the other side as well. Then once again, we can say copy this distance, make 4 copies, make 1, 2, 3, 4, 5 copies actually. Yeah, because the other side has all the purlins. This one had one missing. So now, as far as the other side is concerned, we can zoom in and see that it's more or less done. So what we can do is we can select these purlins over here and copy them to like this, and make 4 copies, 3 copies rather. We can delete the last one. And as far as these are concerned, we will need to go in and delete a few. So I'll just select all of them, right click, say copy, say 3 copies, like that. But we know that this one would be missing because it doesn't match up with anything. This one and this one would need to be deleted, and these 3 would need to be deleted as well. So there we go. We basically have our purlins the way we had them in the model. Now we will do the roof braces and the roof sag rods. If you go back to the drawings, you can see that the roof has its the sag rods going like that, and it also has some roof braces. We'll do those at the end. For the moment, I want to focus on the girts on the 3 sides, and we'll also leave the sag rods on the facades till the end, and the braces. So let's, now that we've done the purlins, we just focus on the girts for the moment. Now, as far as this non-parallel facade is concerned, we have the drawing over here. the non-parallel side, and we have you can see that the level of the girts is given. The first girt is 300 millimeters from the bottom of the column, and then the subsequent girts are 1 meter spaced, and then there is one which is lowered slightly, about 200 millimeters, because it doesn't really fit in there, so it's lowered slightly, and then you've got this area where this one is missing actually completely, but the distances are all 1 meter, and the profiles are UNP 120. So let's just focus on that and get to our model. So let's focus on the first one, which is 300 millimeters above the column. So to do that, what a good idea would now be, because we'll be working on this plane. So in COMOSYS, it's always a good idea to not work in 3D, but always work in the relevant views. So we can create a new view over here. We can create a view by 3 points, or we can also create a sectional view along this line, looking into that direction. And that we can do by using the view with 2 points. So we can let's just use this view by 2 points. Click on that. Click on the intersection point over there, and click on this intersection point over here, and you will see that once I click on that. Oh, hold on a second. I think the work plane was not in the correct area. It's in the roof plane. So better to put it back in the global one. And now we go back to the same command. Click on this point and then click on this point. And now you can see those little arrows at the end. They're pointing in the direction which is perpendicular to that non-parallel facade. And when I click on that, I create this new view. And a good idea is to actually immediately give this view a name. Let's give it a name of non-parallel facade, like by double-clicking on it. And the good thing about working in this view now would be that I will be assured that anything I enter will be in this plane, and I won't be unknowingly snapping to something which is behind this plane or somewhere else. So once you create the view, it's always a good idea to click on this V button over here and bring your work plane to this view as well. And now you can just start clicking basically. So you go to your steel menu and you click on the girts, for example, and let's just create it at the base first. We'll move it 300 millimeters like that. And then we can go back to the 3D view and see how we've placed it. So this is the way it's placed it. Let's click on it and press Control Q a couple of more times, so it's looking down. Now maybe we can click on, or if I just say select origin of interest somewhere over here and see it a bit like that. Click on the girt, press Control W. No, I need to move in the other direction. This is better. And I think the vertical orientation is correct. So this is, I mean, I would basically be needing to just move this 300 millimeters up. But the thing is, if I look at it from the plan view, I click on this 0 button over here and look at it from the plan view, and I zoom in over there. I want this girt to be a little outside. I don't want it. I want it to be on the face, clear, basically clear the column, and I need a number to offset it. Whether it's this one, let's just see. Let's just put a number like that. Oh, this is not the one. Sometimes this needs to be a bit of a trial and error. Yeah, this is the one I'm looking for, the offset I'm looking for, but let's give it a bigger one. Let's try 175. Yeah, this seems to be working. Let's hope it's not clashing with the column at the other end. Yeah, it's just cleared it. That should be enough for me. So an offset of about 175 would work as far as the facade girts on this particular view are concerned. Now that I'm happy with the placement of the girt, I can go back to my view, my non-parallel facade view, and I can create more girts. Let's just go in and create this one like that, and then create this one like that, and create the last one over there like that. And then all I need to do is just select all of these. This one, which I've already adjusted, I can right click and say match elements to this one. So they all look the same now. And if I wanted to select the girths easily, I could just go like that, press enter, click on my beam group, and then just click on girth from there. So now I've got the girth selected, and I can now move them. So the first girth was, if you remember, it was 300 millimeters above. So I can just say move like that. It's moved up. Let's go back to the drawing. So this one was 300, and then we've got 1, 2, 3, 4, 5 more at a distance of 1000. Now let's go back to the model and say copy, and we give a distance of 1000. We say 5, we say copy, and we've got the girths over there. If you remember, one of them was slightly offsetted, so we go back to the drawing. We had this one, but this one was, if we zoom in, we can see that this girth is 200 millimeters below that, because that level it's kind of not getting to the column in a nice way. So this one is offsetted by 200, and the one in the last bay is actually not there at all. So what we do is we can just select this one and say move linear, and in the y direction we say minus 200, like that. It's offsetted now, and this last one just needs to be deleted. Let's go back to our 3D view. Get it like that. If you want, we can turn off the points just to get a better view. And it's always a good idea to turn on your nodes and then press Alt D and see what you've done until you get to the line mode, and see if everything is connecting in the line mode. So we can see that the girths are connected to the columns, the purlins are connected to the roof beams. Everything is basically properly connected. Had we made any mistake, we would have seen maybe these girths slightly not touching the lines of the girths, not touching the lines of the columns or the lines of the purlins, not touching the lines of the roof beams, something like that. So every now and then, or in fact, once before you copy things, it's a good idea to turn on your line mode and see what you have on the screen. And if you are satisfied with that, then you can copy that particular element to wherever you want to copy it. Now that we're done with the non-parallel side, we can come to the front of the portal frame, and here we see that the girths are once again just following the same pattern, 300 millimeters for the first one, and then 1000, 1000, 1000, 1000. But we need the wind columns to be entered first, because the girths will go from this column to the wind column, and then from there to the other one, and continue. And after this level, then we have the girths continue, but they shorten, because there is one girth which, if you zoom in over here, there is this one which is going like that, the UNP 120 girth, this one, which is basically inclined along the roof beam, and these ones are connecting to that. So you can probably see that better over here as well. So you can see that the girths are coming up, and then there is this girth which is coming up, this inclined one along the roof beam slope, and these ones are now connecting to the horizontal ones are connecting to that. Of course, this one is offsetted from the center, just like the other girths over there. So we have to start off with the wind columns, which are at a distance of 4 meters from the left and from the right, and they go all the way to the top wherever they meet the roof beam, and then we'll enter the girths as we discussed earlier as well. So we note that the wind column section is HEA 300, as it was written in the notes as well, and you can see it over here as well. So that those are HEA 300 columns. So we go back to our model, You can turn on the points if you want. And we go to the edit command, and we, because this whole distance is 12 meters and the wind columns are at 4 and 4, so it's basically a division of 3 at that point. So we say divided points, and we select this point. You make sure that you're selecting the correct, you're snapping to the correct point, because at these zoom distances, you might be snapping to the incorrect point, and that's going to create a lot of problems. And when you see, when you snap to the grid points or the endpoints of elements and node points, it's always a red dot, and that's a good sign. So before you click on that, you press 2 so that you get 2 points created in the middle, and those should now be at a distance of 4 meters from the sides, like that. 4 meters between them as well, and 4 meters to the end over here as well. And now we can enter basically the steel columns over there. We need to, let's undo that. We need to bring back the work plane to the global, because these commands always work in the local work planes. Click on that, click on that. Make sure the direction is correct. Yes, the direction is correct. Make sure the profile is correct. It's HEA 300, that's fine as well. And now what you can do is you can select this one, right click, and say with 3 points, and basically show any 3 points on that roof, and it's going to be extended. And select this one, right click, show any 3 points on that roof, and that one is going to be extended as well. If you're slightly unsure, first of all, if you got the nodes on, you'll see the blue node, which means you've connected. But if you're unsure of that, just turn on the line mode and see if everything is correct. So everything seems to be fine. And because this is a bigger column, HEA 300, with a height of 290, so half of that is 140, this will govern basically the placement of the girts, because this one is first of all facing in the other direction. It's a smaller column as well. So what we can do is we can go to our girt command, and once again, from here to here, we can just enter, or let's just first correct this one. We can go, we can double click on this one or press enter and say 145 over here. I think that should work, yeah, because the height of this column was 290, so half of that is 145. So I'm still connected to the column as far as the finite element thing is concerned, and now I'm basically at the correct position as well as far as the offsets are concerned. I can go and look at it from like that and see that I'm in the correct position. Of course, one more thing I need to do is this. So I'm sorry. Control W like that. Yeah. Oh, actually, this is not governing. This one actually is slightly bigger. This has a width of 300, so it's 150. So actually, the smaller column is governing because there was a little clash which I just saw. So what you can do is you can make this 150, and that would be the governing one. There you go. You can look at it from the side once again. And we see that it's now at the correct position. Once I'm happy with that, I can enter the other girts as well, like that, and make sure it's the red dot, like that, and match them to this one, and then move these 300 millimeters in the Z direction, like that. Go back to the drawing. Let's zoom in over there. We can see it's 1,000, 1,000, 1,000, 4 more. We'll empty out this area later. We just copy them first. So we've got 4 more at a distance of 1,000. So let's just do that. Copy, linear, make it 1,000. 4 more copies, like that. Go back to the drawing. Then you've got the next one, which is for some reason 1028. Let's just copy it. We'll talk about the shortening later. Let's just copy the next at a level of 1028. So let's just make it 1028. One copy, like that. Go back to the drawing, and the next one is at 1,000. Let's do that as well, like that. We'll worry about the shortenings later. So come back to the drawing over here, and we see that this area is basically emptied out because there's a door over here, and then there's some vertical girts which form the outer boundary of the door over there, and they're offsetted 500 millimeters using the same profile UNP 120. So how many do we need to empty out? 1, 2, 3. 3 girts will need to be deleted from there, and 2 extra girts will need to be added vertically with the same profile. So we go in there, we empty out these 3, we just say delete, and then we basically need at a distance of 500 from here 2 more vertical ones. So what we can do is we can just enter a column, for example, over here, say dx 500, like that. And then let's see how it works if we just match it to this one. Okay, so it's gone in the other direction. We just double click on that. We say minus 150. Okay, something else is needed over here. So it's actually going to be not this, but it's probably going to be this. Let's just move it to the side. No, it's not that as well. Let's just hold on a second. First of all, let's bring it to the right level. The height needs to be whatever this height is. Let's measure the height. The distance from here to that one is we deleted 3, so that distance is 3,300. So this basically this column would need it to be a height of 3,300. So what we can do is we can click on this, say 3,300, and click on this pink button over here to shorten it. And now basically if we just we can see that it's correctly oriented over there. We just need to give the offset over here, I think. Now let's make it 150, the same as the other ones. And we see that the vertical column, which is also a girt, part of the girt structure, has been entered at that point. And if we just wanted to check by pressing Alt D, we see that everything is connected in the line mode as well. Once we are happy with that, what we can do is we can select this one and say copy mirror, and we can select the midpoint of the grids like that and say run, and we have it on the other side as well. So that was a quick way of. We'll worry about these in a second. Now that we're done with this side, let's talk about the top over here. First of all, we don't need these 2 at the end, so we can just delete them. But what we do need is an inclined girt going like that. So going back to the drawing, you can see it in the 3D over here. This one. Now, when we're talking about this one, normally the first thing which would come to mind, since we've been mentioning this whole thing about making sure your definition lines are correct and then you offset them. So what one would assume immediately is that we go to our girts command and we enter that girt from in the along the roof beam, basically, like that. But this and then basically you bring it down like that, and you give it an offset of 150, and you bring it so that the outer face is the same as the other girts. But this is a bit problematic in this particular case, and this is a case where you would need to make an exception to that rule, because in COMOSYS, 2 elements cannot share a definition line when there is an overlap. So already we have the roof beam over there. So unless you wanted to, so if you wanted to use this particular point as your point of entry, then you could do that. Then you couldn't do that. But if you wanted to use some other points, then you could. But if, let's say, in our case, if you want to use these points, then instead of giving this an offset, right now, I could give this an offset of, say, 150, like that, right? And basically, it'll be the outer face will be the same as that of the girts. But right now, both this one and the roof beam are occupying the same line. And therefore, it will cause a confusion with the IntelliClone technologies, because which one belongs to which will become an issue, because that whole thing is based on definition lines. So in cases like this, these are like special cases, they don't occur often. But when they do, the recommended one way to do it could be that you don't give that an offset, but you actually physically move it so that it gets separated from the roof beam. Like that, and you say, for example, you move it like that, it's at the same point, but now in the line mode, it's actually separate from the roof beam. And that can be accepted because what it means is that a few nodes over here, you will not be able to use IntelliClone when you're doing little things like this. And that's fine as well, as long as it's not too much. Another option could have been that you don't use the roof plane, the roof beam line, and you use some other line which is slightly elevated perhaps, and then use the offsetting to get to the same location. In fact, we can try that. So instead of not following the rule and physically moving it, we can actually do it in a different way as well. And that would be that you you create a point slightly elevated. So I've created a point which is at a distance of 100 millimeters in the direction perpendicular to the roof at that point. And we use those points so that we don't have an overlap with the roof beam. So you could go in there and use this point rather than the point of the roof beam, and then a similar point on the other side as well, like that. And now what you could do is you could select this and press Control W to bring it down, and give it the offset of 150. Before we do that, no, we need to give another offset because this distance was 100. So I'll give it 100 to bring it down to the same level. So now it's exactly at the level of the roof beam, but physically it's separated. And I can give this one an offset of 150, like that. So once again, now I have my this inclined girth in the right position, and if I'll go into the line mode, you will see that it is slightly elevated from the roof beam. Now, all I need to do now is pull back this one, so that it meets that one over there. And to do that, what I can do is I can just select on that, say right click, and say frame editing to 3 points, and I can just select that point, the definition point over there, the definition point over here, and then just anything in the roof plane. So I can just say maybe D by 100, whatever. When I do that, you hold on a second, just a second. Yeah, I realize I shouldn't have picked these points. I should have picked these points because that's where that's where it's been offsetted to. So I'll just do it again. Just select that one, say 3 points, and select this point, which is the roof beam point, because I know that now the girth has also been offsetted to that plane. So that's the reason. And then this one, and then just give any Y offset from there to get the right plane. And you will see that this particular one has been pulled back to that point. Now, you can do the same thing on the other side as well. Another easier way to do it would be to just delete this one and select these two, this one and this one, and perhaps mirror them. Let's go copy mirror along the middle of the portal frame, go like that, and it'll be brought to the other side as well. So that's basically, and I can pull back this one as well if there's a slight mismatch over there. So this is an easy way to make these little modifications, these extend to the plane, and making sure that the nodes match up and all that. those are things which you'll get used to as you move along in your modeling experience with COMOSYS. Now, coming back to the drawing, we want to do the backside, the girts on the backside as well, and the drawing is over here. We can see that the girts are pretty simple, following the same pattern of 300 and then 1000. So we go back to the model. We can easily enter it directly over here as well if you want to. So we could go to our girt command over there, click on that, see what the height of the column is. It's HEA 300. Oh, hold on a second. Actually, we've not changed the height of the outer. The main columns were all actually 260. So that's a little mistake we've done. What we need to do is select these columns and this one as well. Let me see what these ones are. 300. Okay. So we're just going to make them all 260. That's fine, because it's not really going to affect anything. Make all of these HEA 260, because that was what was the requirement of the drawing. And this one has then a height of 250, so this skirt would need to be offsetted by 125, I think. There we go. Let's look at it from the side, see if it's at the correct point. You can click on this ortho button to just get an exact one. Now we need to bring it over at that level, and that's fine now. Now we can easily continue with our girts like that, like that, like that, and then just select them, right click, match them to this one, select them again, right click, copy them, move them rather, 300 millimeters in the Z direction, like that, and then we can copy them the distance of 1000. I think it was 4 copies. Let's go and check the drawing again. 1, 2, 3, 4 copies. Yeah. So just enter 4 over there, and you will have your girts on the back side. Once again, like we said, we've left the sag rods and the bracings for the end, but the girts are there. Let's see if there's another girt in the drawing. Let's look at the 3D. Maybe there's a girt over there. Is it clear from this drawing over here? So yes, there is actually one more girt, which is at a distance of 650 from the last one. So we go back in there and we select our top girts, right click, copy, and instead of 1000, we say 650. And that will be it for the girts on that side. Now let's talk a bit about the sag rods. So this is the view on line B, which basically is the back side. This is the axis B. So if we zoom in, we see that the sag rods are basically, so the distance is 5 meters between the columns, and it's basically divided into 3 pieces, 1, 6, 6, 7 each. And if you zoom in, you will see that this 1, 6, 6, 7 is actually this point. It's neither this sag rod nor that sag rod. Each sag rod is offsetted slightly, one to the left and one to the right. That's this 1667 distance is the definition line distance. So maybe there's a detail one. If we go there, you will see that the sag rods individually have been shifted 50 to the left and 50 to the right, but the definition line has been defined as 1/3 of this 5,000, and this is what we need to keep in mind. And then when it comes, so they go like that in a staggered way, one on the right, one on the left, one on the right, one on the left, and the profile is D20. And then as it gets to the top, at the end, there's a little angle, 60 by 60 by 4, and the inclined sag rod is also D20. But if you just need to take a look at this, maybe we have another detail regarding this inclined one. Yeah, so this detail 2, gives the distances. Let's go and see it from here. Yeah, here you can see that this is the definition where the definition lines meet. 50/50 is the vertical sag rod, and the 50 is for the angle as well. And as far as the inclined one is concerned, it's offsetted 200 from the definition line point. So we just keep these numbers in mind. What we need to do is work on the view on line B, because it's always better to work on the 2D plane. So we go back to the model, and we see that we already have the view on line B defined over here. If you don't have it, you can just click on the grid and right click and say grid, create views on grids, and these views will be created. And if you double click on the line B view, this is what it looks like. And we should always immediately put our work plane by pressing this V button, work plane into in that view. And if you remember, this 5 meter distance needed to be divided into 3 parts. So we can just go in and go to the points command and say dividing points. And this was the GERT. This is my GERT coming in. I can just click on this working point. I just need to make sure that I'm clicking on the right points. And before I click on this one, I keep the key, the 2 number key pressed, so that it's divided into 2 parts like that. 2 points are created, equidistance. We can, in fact, it's a good idea to measure the distance between them, 1667. That's correct, 166.66, which is basically rounded off to 1667 in the drawing. And then once we have those points, we can either continue by using the same tool, like that, and like that, press on 2, like that, press on 2, like that. We could have just copied the points as well. Make sure the red one is the one which lights up the snap button, because that's the correct one. Now we go back to the drawing, and we see that the sag rods start off from here, D20, D20. They go up like that. So let's come back to the model, and let's create a beam. Let's create a vertical. Let's just create one like that. Okay, let's see where it is. Let's create these 2. And the profile was D20. So we'll just enter D20 like that. We'll bring it in the middle. Instead of the default beam, we just say middle 0 and see where it is. Let's just delete this, in fact, because let's work on 1 to see where, to ensure we're at the right point. So this is, we've entered it middle 0. Let's go to the 3D view to see what we've done. Yeah, this is what it looks like at the moment. It's if we turn on the line mode, Alt T, you'll see that in the line mode they're connecting. But because the GERTs have been offsetted by 125 because of the column, we will need to offset. This one is right now in the middle of the column. So the column itself was 250. Half of that is 125, and the GERT was 120. Half of that is 60. So 60 plus 125 is 185. So what we would probably need to do is put a number like 185 probably over here. See, yeah, you can see that it comes to the middle of the GERT, which is exactly where we want it. If we click on Alt D, we can see that in the line mode they're still connecting. So it is correct. It is where it should be, but not exactly. So we go back and we see that this one actually needs to be shifted 50 millimeters to the right. And this one also needs to be shifted 50 millimeters to the right. So how do we do that? Once again, we do that by offsets, because the definition line shouldn't change, and we say 50 over here. It's gone in that direction, if you notice. Now that I have that, I can now go back to my other one. In fact, before I copy, let me just convert this beam group to a sag rod rather than a beam, because that's also going to be helpful later on, maybe. And then once I'm done with that, I can just say copy linear from this point to this point, like that. And I've got my first two sag rods in there. Now I can select both of them, say copy from there to there, like that. But this time I'll select both of these. Instead of giving them the offset of 50, I'll give them the offset of -50. And see where that's going to take me. Yeah, there you go. So the definition lines are in the middle, and they've been offset at 50. If I were to look at them in the Alt-D, you see in the line mode, that's where they are. But in the actual physical, the physical locations are actually offsetted. And I can select these two now. Since I know these distances are all 1000, I can say copy, so that this point goes to that point. And we've got that. And for the last one, let's see what we had. We had the last one would be an angle, L 60 by 60 by 4. So we can actually do the same trick again. We can enter. Actually, what we can do is we can just copy these ones if you want to. Just copy them linearly from there to there. That would be one way of doing it, and then we could bring this. So we know the height over here. Since we know the height to be, let's just measure this distance. 650 as far as I remember. Yeah, 650. So if we can just click on this, let's turn on the handles. Click on this, and if we click on this, make it 650 from the pink side, and do the same with the other one, like that. We will have those two over there, but the profile needs to change. Let me go and check that again. It's 60 by 60 by 4. So I'll just select both of them and say L 60 by 60 by 4, like that. And obviously the offset needs to be reversed. So whatever the offset was over here, it was -50. It needs to be +50, because I just copied it from the other ones. There you go. So as far as the orientation of the angle is concerned, let's go to the 3D view. It looks kind of okay. If you wanted to, we could rotate them and bring them in a better position, but this looks fine as well. Now, going back to the drawing, we see that these ones, the inclined ones, are actually offsetted in a different way. We just checked the other view for that, and we said that their offsetting distance is actually 200 from the definition point, and the profile is still the same. So to enter it, what we could do is we could just come to this facade and enter the beam command. Start from the definition. This is the definition line, and this is the definition point at the other end. And then just select this one and, for example, match it with this one. But with one exception, you just first double click and you remove this offset of 50, so that it's exactly at that definition point. And now we need to shift it 200 millimeters to the right over here and 200 millimeters to the left over there. And to do that, we know the easiest way is to use these handles. This is the X direction, so we click on this blob over here, and we say 200 in the X direction, say move, and that will basically move the working point. Physically, it'll still be there as far as the line mode is concerned, but it'll be offsetted, and we can do the same for the top over here. I'll give it an offset of -200, like that. So very quickly, we have the sag rods. If we can do the same thing on the other side as well. If we go to the 3D view, we can see that we have the sag rods exactly where we want them. Now we can make our connections later, obviously, but this is not part of this assignment. We need to we can mirror this along the middle of this grid line as well to get the other one, and then we would just need to copy the whole thing in the in the x direction in this case. So let's do that. In fact, let's just select this last one which we entered, and right click and say let's put the work plane back into the global so that we can do the mirroring correctly, and say copy mirror, and select the middle of the grid over there and the middle of the grid on the other side, so that we have this mirroring plane, and we offset our sag rod like that. Now to select the sag rods, all of the sag rods, we can just go select all that, change to the beam group, and say sag rods, and we can see that we've selected all the sag rods over there. And now that we have them selected, all we need to do is just copy them in the y direction at a distance of 5 meters, like that, and we've got 3 copies. So with a simple few clicks, you can see that if you turn back the line mode, you can see that everything is properly connected in the line mode. And in the 3D view as well, let's turn off the nodes. Everything is in its proper place. Now, obviously, the purpose of these assignments is to make you use the manual commands and not use the macros, because it is it's only when you get very acquainted with the manual commands that you really become a good user. Otherwise, to do a lot of this stuff, you do have macros available. For example, we just entered all these sag rods on the back side. I'm just not going to waste time, because you already know how to do it now manually, and I would recommend that you do this side yourself manually as well. But in the structural members menu, you see this create sag rods over here, and you basically, what you do is you select the bottommost skirt and the topmost skirt, and then you just right click. You could show it a point as well, but you just right click, and it's going to basically create those what we just did. And then they show this one and that one, right click, this one and that one, right click, and this one and that one, right click, and basically you have your sag rods very quickly done the same way. All these once again, if you turn on the Alt T, you can see that they're all entered in the line mode correctly. The finite element definition lines are correct. So what we did in perhaps 5-7 minutes, we managed to do in 5-7 seconds. But it's a good idea to always work manually in the beginning, so that you know exactly how to get these things done, just in case a macro is not available. If we wanted to finish off the roof sag rods as well using the macro, we could just click on this and click on this one, and the last purlin over there, right click, then this purlin and the last purlin on this side, right click, this one, that one, right click, this one and that one, right click, and then do the same for the other side, this one and this last one, right click, this one and the last one, right click, this one and this one, right click, and do the same for the last one as well. And basically that would be the end of all the sag rods. If you feel you're comfortable enough doing it manually, then you can continue with the automation. Now let's go back to the drawing and see that we have this section, this pipe section going all across. It's the CHS 88.9 by 6. This one over here, it's shifted 150 below that apex point. We can see it in the plan view as well. You can see it over here, CHS 88.9 by 6. This is the one which is going all across the building. 1, 2, 3, 4, all the bays. So let's CHS 88.9 by 6. Let's just enter that. We go back to the model. We can call this a roof brace or a vertical brace. That let's turn on the nodes. So we're snapping to the correct point. Let's snap to this point, and let's snap to this point over here. It was double click on that, CHS 88 point something. Was it this one? Yeah, 88.9 by 6. Say apply like that, and then give this an offset of minus 150 perhaps. Yeah, there you go. So this is where it was, like this, right in the middle of the, because the height of the roof beams is 300, so it should be in the middle. That's why it's lowered 300. And what you can do is now continue with the rest of those. Go like that, from there to there, and from there to there, and then just select them and right click and say match elements with this one, so that they all come to the middle of the roof beam as shown. Now let's talk about this eaves beam, which is basically a folded plate of thickness 4 millimeters. You can see it over here like that. If you go to the sectional view, which is you see we have this AA section looking into it. You can come down here, and here we see what it looks like. So it's a folded plate basically, and its top is aligned with the top of the purlins of the roof, and the back is aligned with the girts on this non-parallel facade. The height is 180 millimeters. The width in this is 120. This one also has a projected length is 120, but it's along the slope of the roof. And then there's a little lip of 20 millimeters over there. So how do we go about creating? We use the folded plate command for this, but to initially get our bearings, perhaps one way to do it would be just let's enter a normal girt over there and see what happens. So let's go back to this non-parallel facade view, this side, the view which we had created for that. Let's go in there and put our work plane over there as well. And let's try to create a girt from the top of the columns. This is the top of the column. From those points to this lower point, and then from there to there, like that. I'm just creating these temporarily, just to see. And then our girts were actually shifted 175. So what I'm going to do is I'm going to make them all match the girts. Right click, say match elements, like that. And let's go to the 3D view to see what we've done. This is right now this girt is aligned, this inclined girt like that is outer face is aligned with the outer face of the girts. But obviously that's not our only requirement. We need a folded plate over here in such a way that the outer face is aligned with this one, and the top is aligned with the roof. So that's a bit of a tricky situation. Now we recall that our girt was UMP 120, which means this length was 120. So we already and we also know that this length is 120 as well. So that's a good. We can just use the same points. It's just the top slope which is going to create a problem for us. So we need the points basically to enter the folded plate. So what we can do over here is because we know this 120 width is good, what we can do over here is go to the edit command and go to this command of line plane intersection, which allows us to get the intersection of lines with planes. And when we do that, it first asks us for a plane. And for the plane, I'm going to select the roof plane, the top of the purlin. You can see that. So I'm selecting that purlin. And now it's asking for 2 points to define a line. And I'm going to define this inside of the girth because this line needs to be the same because it's going to be parallel with the girths on that facade. So I'm going to define this line, and it's going to create a point. If I turn on the points, it's just created this point for me. This point is basically in the roof plane, in that plane. It's as if that plane is continuing, and it's going to hit at this point. And since it's still in the command, it's asking for a second line. I'm going to give it this point and this point over there, and it's going to create another point. And both these points are in the roof plane. So I right click and I get out of the command. I go back to my drawing and I see that the height is 180. So what I can do is, and this lip is 20. So let's go back to the model. So from this point, I want to go down 180. So I go to my extension. I click on the shift key, say minus 180, like that. And I can just select this bottom point and go to this point. And so this height now becomes 180. And for this one, what I need to do is I need another point which is 120 away from that point, and I want a lip point 20 millimeters below that. So let's go to the extension point again. This time say minus 20, and I can just go from here to here to create that point. And then to create this point over here, which is basically this point over here, it's 120 millimeters away from that. All I need to do is just select this point and say copy from here to here, from here to here, like that, and I get my other point as well. Now I've got my points for that folded plate basically, which will be inclined in such a way that it'll be inclined along the top of that folded plate will be in the plane of the roof. Now I'll just go to my steel menu over here, go to my plate commands over here and select the folded plate option. And I'll just go over these points like that, and like that, and just say right click. And when I do that, a little folded plate is created over there. And I can double click on that and turn the thickness into 4 millimeters, which is what I wanted. Leave this one, because I need to measure it. So let's just reduce the thickness like that. Let's zoom in and see where the points are. So let's keep it behind. No, let's keep this one middle. Let's keep this above and see what happens. Yeah, we want the outer ones to be like that. And if you say behind over there, no, rather front. Yeah, yeah. Now my folded plate is has been positioned in such a way that the points I've chosen are like that. As you can see, those are the correct points, and it's pointing in that direction. And now if I change this, if I just give it the thickness of width of say 3000, length is going to become 3000, but I need to exactly measure what the length of my girth over there was. So I can just select the girth and see that the length is 5138.7. So I can go back to my folded plate and say 5138.7, like that. And basically I can now delete the girth because I no longer need it. And if I wanted to, I could give this one a different color so that it looks better or looks different from the others. There you go. And now I can basically copy it so that, and I don't need the other girths, but I can just copy this one. Let's see if the lengths of all the other ones are the same as well. Yeah, it's all 5138.7, 5138.7, 5138.7. So what we can do is we can select this and say copy linear and go from this point to that point over there, and that will be basically that, and 1, 2, 3 copies like that, and we'll have the others. We can now just go in and delete the temporary girts which we created. In fact, we didn't need to create all of them. We could have just created the last one. But there you go. You have now, let me turn off the nodes. You have created this eaves beam, which is actually in alignment in such a way that it's, if we were to find an angle to view it over here, or actually the best way to look at it would be maybe the section of this plate. We can actually create a view to do that as well. But basically, this top of the folded plate will be in complete alignment with the roof plane. So I've created that view over here, taken a sectional view from that folded plate, and as you can see, the top is perfectly aligned with the. If I put my work plane over here, I can actually put some construction lines over here to see. If I put my construction line from there to there, you see that it is going and meeting up with the purlins. And if I put a construction line from the back over here, you see that that one is meeting up with the girts perfectly. So this is exactly what I want for my cladding to come like that and then continue over here with this eaves beam. And that was basically the tricky part of this whole exercise. With this exercise, I mean, we can we go what we have left right now is the roof bracing basically, and the vertical bracing over here. Those are the only things left from this assignment, so we can do that now. But the tricky, those would be easy. This was perhaps a bit tricky. The creation of the columns and the sag rods and perhaps some of these girts were a bit tricky, but all this will teach you how to model. And if you notice, we have never strayed away from our fundamental principle of keeping everything in line mode, strictly connected. Turn off the nodes and everything will be perfectly connected. And this will come back to benefit you, because once you have this kind of a setup and you, like I said, in COMOSYS, it works either way. Even if you don't pay attention to this, the connection macros will still work. But if you do pay attention to these, then you will be using technologies like IntelliConnect and IntelliClone, and they will really allow you to do your work several times faster than what you would normally achieve by just using macros. Now let's just finalize everything with these vertical braces, which are basically CHS 88.9 by 6. They're coming like this, and the midpoint of the column is at 2,500. This is the backside, which is symmetrical, or rather aligned. And then there's one going all along on the side as well, CHS, the same profile. And they've been obviously at the top, it's lowered by 150 because of the height of the roof beam. So let's go back to the model. From this is let's put our work plane in global. To begin with, we go to the steel menu, we go to our vertical bracing. This is our working point of the brace, and we go inside and we can actually just match it with the other one. I think we just created one over here. That was the one, and it was lowered by 150 as well. There we go. So we want this offset of 150 in this one as well, because the height of the roof beam is 150, so the middle will be somewhere over there, and we've lowered that, and then we can continue like that, over there. Always make sure you're connecting to the right point. select the 3, come here, say match elements, and there you go. Just check your line mode if you want. You should always have a clean look like this. Okay, you're done with that. Now basically you want 2 braces coming in like that, and then 2 like that. Let's go back to the drawing and see. Yeah, there's 2 of them like that and 2 of them like that. Of course, this one, the start point of this one will need to be shifted 150 as well. The others will be centered. So we go to our line B once again. Go to view on line B. Put our work plane over here. That's the best way of working. Go to your vertical brace. This was the working point. We can check by right-clicking and measuring the distance from here to here, 150. That's correct. So go back to the vertical brace from here to the middle of the column. If you can snap to it, that's fine. I'm not sure. So what I'll do is I'll come over here and say DY 2500. That will be cleaner for me. And then do the same thing from here, like that. Basically, what we need to do is now make sure that it's the same one as this one. But I'm going to remove that 150 from in there. I just want it middle, like that. Oh, I think I chose something incorrectly. I should have chosen this one. Yeah, there we go. And then we remove all offsets, make these 0, middle. Yeah, that's better. And the only thing we need to do now is to lower the working point of this end, only the start end, by 150 as well. So we select this, put it in a better draw mode if you want. You can select this. We can select this blob over here. And since it's the Y direction, we go over here, say -150, move. And now the working point, because this one was lowered 150 by using the other offset, by using this offset. So that offset obviously worked for both the start and the end. But in this case, we only want the start to be shifted and not the end, because the end is correctly placed. So we use that adjustment to get to that point. Now that we have the braces, we can just copy them. Say right click, copy. So this point gets to this point, 15,000. That's correct. And basically, I'm good to go. Now, if you notice, we've been working on this. I mean, the same thing will be done. You've created the braces over here using the same methods. You can work in the non-parallel facade view to create the braces over there, and then you could create a view on the roof to basically create the roof. Let's see what we have on the roof. We've got just 1, 2, and 3, and 4. Let's look at it from the top view. We've got this one and this one and this one and this one as far as the roof is concerned. So very similar to what we've already done. It's perhaps going to take you another 2 minutes to enter those. But if you notice, we've been at this for about an hour, 10 minutes. And I've been explaining stuff as well. So you can foresee that once you become proficient, once you become good at modeling in COMOSYS, and you're on your own, you could be finishing off this whole structure. Only the frames, obviously, not the connections. You could be finishing it off in say an hour or maybe even less. So that's not a long time. And once your muscle memory develops, you know where the commands are. That should be the when you look at something like this, you should be saying, I can probably do this in an hour. and we've demonstrated that it is doable. So we hope you enjoyed it, and just practice as much as you can. And the more you practice, the faster you'll become.